Hello, this is Ms. Johnson. This is MAT 221. We are in section 3.6, which is derivatives of inverses and inverse trig functions. Please pardon me for my voice, my lack of voice. So in this section, we're talking about a little bit about the trig functions. Now, we may have in class talked about a really brief review of the trigonometry that I expect you to know for calculus from previous math courses. Remember we filled out this table to give us those values of the sine and cosine of those most common angles of 0, 30, 45, 60, and 90. And then from that, we can get the tangent of each one of these angles by using sine divided by cosine. And we could develop this table relatively quickly. Remember from pre-calculus and from courses before pre-calculus, the whole concept of an inverse function is an inverse of another function if it is reflected over the line y equals x. That when the x and y interchange and then we solve again, we get another expression that is known as the inverse. Now, the inverse is a function if it also will pass the vertical line test. And you can see from figure 1 that the sine function is not considered an invertible function or a function that is easily just found the inverse of. That its inverse, if I just reflect the sine function over the line y equals x, it does not actually get me a function. It is not considered a one-to-one function or invertible function because it fails what's called the horizontal line test, which remember was a test we tested to see if something was one-to-one or if that its inverse was also a function. So what we did in pre-calculus is, in order to cause an inverse function for the sine function, we limited the domain of the sine function to give the largest piece of the sine function that would still pass the horizontal line test. In other words, if we cut off the sine function from negative pi on 2 to pi on 2 and just look at this piece of the function, if we just look at this piece of the function from negative pi on 2 to pi on 2, notice the sine function now becomes invertible, or in other words, it can have a inverse, which is also a function, because this piece of the sine function passes both the vertical line test and the horizontal line test, therefore could be invertible. Then what we did is we then found its inverse function. We changed the x and the y, and we solved again for y to get this new function. Now notice the input for the sine function here, when we just look at its small piece that we took, is all the angles from negative 90 degrees to positive 90 degrees, or from negative pi on 2 to positive pi on 2. And the output of this function was the sine of that angle. So the sine of negative pi on 2, which was negative 1. The sine of 0, which is 0. The sine of pi on 2, which was positive 1, was the output of that function. Remember, when we take an inverse, the input and output reverse or change. So now when we do an inverse function, the input is going to be a number between 0 and 1, and its output will give us any angle, as long as the angle is between negative 90 and positive 90. So the inverse function of this restricted sine function exists and is denoted by sine inverse or arcsine. I like arcsine better only because this symbol sometimes confuses students as a reciprocal function, which it is not. It is called the inverse sine function or the arcsine function. And since the definition of an inverse says that an inverse then reflects, remember, the x becomes y and the y becomes x, right? The input is y and the output is x. We have that the inverse sine of x equals y is equal to the sine of y equals x, and that my y's are my input of the inverse sine function are any angle, my output is only any angle between negative pi on 2 to pi on 2. Thus, if we find a number between -1 and 1, the arcsine, or the inverse sine of that number, is going to give us an angle between -π/2 to π/2, whose sine is equal to x. So let's just do a couple of examples. Again, this is a review of pre-calculus. This is not any calculus stuff yet. The first one says, find the sine inverse of 1/2. In other words, we say we want to know what is the angle whose sine is equal to 1/2. And from our table, we know that we have the angle whose sine is 1/2 is π/6, or 30 degrees. So since sine of π/6 is equal to 1/2, and sine of π/6 lies in the given output of our function, which is from -π/2 to π/2, π/6 is our answer. Let's do part B. Part B says we want to know the tangent of the angle whose sine is 1/3. Well, the first thing I want you to notice is that 1/3 is not on our chart. So we can't just go to the chart to figure out what is the angle whose sine is 1/3. So we have a different method that we came up with in pre-calculus. What we did was we drew a reference triangle. We said, well, if the we want to know the angle whose sine is equal to 1/3. So we draw a little reference triangle in the first quadrant. We know that the sine is positive, so we know sine is positive in the first quadrant. So I draw an angle so that opposite over hypotenuse is equal to 1/3. And I use the Pythagorean theorem to find out what the other side of the triangle is. The other side of this triangle is 2 radical 2, or radical 8. Then we actually answer the question. The question says, what is the tangent of the angle whose sine is 1/3? Well, theta has a sine of 1/3, you can see it, and the tangent of theta would be opposite over adjacent, which would be 1 over 2 radical 2. So I can find the tangent of that angle. Notice I don't have to find the angle here, I just have to find the tangent of the angle. So the tangent of that angle from the reference triangle is equal to opposite over adjacent, which is 1 over 2 radical 2. All right, those were two methods we learned in pre-calculus to find the sine of an angle, or an angle in the first case was finding an angle. The cancellation equations for inverse functions become, in this case, that if I take the inverse function of a sine function, remember an inverse function will undo itself, will be true only if my angle is between -π/2 and π/2, because we can only do this in the limited case where I have a horizontal line test passing. And if I take the sine of an inverse sine function, this will only be true if my sine is between -1 and 1. So now let's look at the calculus part of this, and let's give you the 6 trig functions that are the inverse trig functions. They are these functions. First is the derivative of inverse sine. The derivative of the inverse sine function is equal to this equation, 1 over radical 1 minus x squared. The derivative of the inverse tangent function is 1 over 1 plus x squared. And the derivative of the secant function, inverse secant function, is equal to 1 over the absolute value of x times radical x squared minus 1. Now, a couple things I want you to notice. These are very difficult formulas, and so yes, they're going to be difficult to memorize. But notice they're also very similar to each other, so they're very easy to confuse. How I usually remember these is by looking at the actual function itself. Notice Tangent begins with a t, which has a plus sign. It almost looks like a plus sign. So I say to myself, it's the only one with a plus sign is tangent. And tangent, because of the plus, also does not have any radical. So it's the easiest of the three inverse tan functions to remember. It is 1 over 1 minus x squared. Excuse me, 1 plus x squared. Now the sine and secant are the tougher ones. And the difficulty for me is always remembering, does the 1 come first, does the 1 come last? And if this helps you, that's good. If it doesn't, that's okay too. But how I always remember it is I look at the sine function and it looks like this, the I almost looks like a 1. So it's kind of like a reminding me that with the sine function, 1 comes first. Both are subtraction. So it's radical 1 minus x squared. With the secant function, there's no little I there. So 1 comes second in my expression. And it's also the longest formula because I have to tack on this front piece to it. I'm going to give you the 3 other formulas, and you'll notice that they're very similar to the 3 we just did. Notice they're identical. The only difference is that they're all negative. And just like with the trig functions for sine, cosine, tangent, cotangent, cosecant, and so forth, remember all the c functions were negative. The same thing occurs here, that all of the c functions have a negative derivative for inverse. Notice sine and cosine are linked, tangent and cotangent are reciprocal functions, so they're linked, and secant and cosecant are linked also. So notice they're identical to the other function, it just has a -1 attached. Now I will try to put up another video when I have a little bit more of a voice so that I can show you some more examples of these and using these. In the meantime, you can go to the worksheet folder and look at some of the worksheets on the derivatives of inverse functions and try some of those problems yourself. Good luck and have a good day.